Assalamu alaikum friends, my name is Albert, and today we are going to attempt the last numerical of the chapter 11. So in this record, I'm going to read the statement of the numerical, and the statement is: a sound wave has a frequency of 2 kilohertz and a wavelength 35 centimeters. How long will it take to travel 1.5 kilometers? So what magnitude of physical quantity have been given by the examiner? The examiner has given us the magnitude of the frequency of the sound wave, which is equivalent to small f, which is equivalent to 2 kilohertz. And in SI system, the units which are used to express the magnitude of frequency are hertz. So to convert kilohertz into hertz, I have to replace or substitute the value of kilo, which is equivalent to 10 to the power plus 3, 10 to the power plus 3. So I have put the standard reference on the right hand side of the paper, and which is 1 kilo is equivalent to 10 to the power plus 3. So by replacing the value of 1 kilo, I'll get the answer of kilohertz in hertz, which is equivalent to 2000 hertz. Okay. Wavelength of the wave is equivalent to lambda is equivalent to 35 centimeters. So to convert centimeters into meters, I have to substitute the value of 1 centi, which is equivalent to 10 to the power minus 2. I have also written it as a standard reference on the right hand side of the Excel sheet as well. So you have to put it as a standard reference on the right hand side of the paper on which you will work or you will be working in the future. Total distance traveled by the wave, which is equal to small s, is equal to 1.5 kilometers. So to convert kilometers into meters, which are the SI units of distance, I have put again the value of 1 kilo, which is equal to 10 to the power plus 3, 10 to the power plus 3, and I have written it has a standard reference. So 1.5 kilometers after converting 1.5 kilometers into meters, it is approximately equivalent to 1500 meters. So what I have to find? I have to find magnitude of the total time taken by the wave to cover the distance, which is 1.5 kilometer. Delta T I have to find. Okay. So using formula, if I have given the total distance covered by the wave, and I have to find the total time taken to cover that particular distance, so I can use the formula total distance covered is equal to average speed with which the wave is traveling multiplied by total time taken to cover that particular distance, as it is the equation 1. So we know that the examiner has given us with the frequency of the wave, with the wavelength of the wave, with the total distance covered by the wave, but we have to find the total time taken to cover that particular distance, but we don't have the magnitude of the average speed with which the sound wave is traveling. So to calculate the average magnitude of the average speed, I have to multiply the frequency of the wave with the wavelength of the wave so that I can estimate the magnitude or anticipate the magnitude of the average speed. So first of all, we have to calculate average speed. So using formula, average speed is equivalent to frequency multiplied by wavelength. By putting values, I'll get frequency. The magnitude of frequency is approximately 2000 hertz, multiplied it with the wavelength, which is in meters. So the average speed with which the sound wave is traveling is 1700 meters per second. Yes, sound wave is traveling is 700 meters per second. So now put values in equation 1 to calculate total time taken by the wave to cover that particular distance. So to calculate the total time taken, average speed is multiplying on the right hand side of the equation. So after shifting it on towards the left hand side of the equation, it will be divided with the factor of total distance covered. Okay, so the total time taken is equivalent to total distance covered by the wave divided by the average speed with which the wave is traveling. So you'll get the answer, which is 2.1 seconds. I have restricted it up to 2 decimal places. So that is the end of the numerical 11.9. So and that was the last numerical of the chapter. So if you have any query, you can contact me, or you can clear it in the physical classes or in the live classes as well. In the previous numerical, we have tried the magnitude, which is the magnitude of the wavelength of first wave, which is equivalent to 0.01715 meters. You have to write it in standard scientific form, and you know very well what is meant by standard scientific form. Okay, so that is the end of the video as well. So take care. If you have any query, you can contact me. Take care. Allah Hafiz.